The James Webb Telescope in 2023 has given space travelers an invaluable gift. The observatory's scientific program Cosmos Webb has created a unique brain image of 25,000 galaxies, the best guide to the galactic expanse of the universe. There are objects for every taste: beautiful spirals, bright lenses, jellyfish, and light bulbs. In this celestial guide, you can find any route for the most discerning travelers. But this is only 4% of the data that astronomers are going to get in the course of the entire project. They intend to map the earliest structures of the universe and conduct an in-depth study of 1 million galaxies. That sounds like an incredible number, but it would cover just 0.6 square degrees of sky, which is roughly equal to 3 full moons. However, scientists are constantly finding new galaxies, and each one is unique in its own way outside the cosmic web. There are beautiful flowers and colorful fireworks, scary zombies and cannibals, mysterious yeti. That's where our space journey today is going to be. Oh, and at the same time, we'll see if the Milky Way really is a luminous spiral, as is commonly believed. Astronomers have some doubts about it. To find out, let's quickly continue on our way. In space, there are many structures that look like blurred clouds with stars inside. There are galaxies and nebulae that look almost identical from Earth. But we are interested in the first. And in order not to get lost, let's define the differences between galaxies and nebulae. Until the 20th century, astronomers didn't know there were galaxies other than the Milky Way. All the other bright spots in the sky were classified as nebulae, what any long-lived astronomical objects were called. According to this definition, many galaxy star clusters have fallen. For this reason, our neighbor, the Andromeda Galaxy, used to be considered a nebula. It was only in the 1920s that astronomer Edwin Hubble found out that Andromeda is actually a galaxy. The development of astronomy and the improvement of telescopes allowed to more accurately determine the difference between these objects of distant space. Now, galaxies are considered gravitationally bound systems of stars, star clusters, interstellar gas and dust, and planets. And nebulae are those parts of the interstellar medium that stand out against the sky. Galaxies, each containing an average of about 100 billion stars, vary greatly in size. There are dwarfs with less than 100 million luminaries and supergiants with 100 trillion luminaries. Take a look at the Alkean Galaxy, about 3 billion light-years from Earth. On the surface, it's just a bright spot in the sky with twinkling stars. But astronomers consider this object a true cosmic monster. Alkeans were discovered in 2022 in the constellation Rhesus. The number of giant stars has not yet been accurately calculated, but it can be estimated based on the already known mass of the galaxy, 240 billion solar masses. So there could be billions of stars in the Alkean Galaxy. In telescopes, it can be seen as a star orbiting a core with a supermassive black hole at its center. This hole ejects from the heart of the galaxy colossal jets of glowing gas and dust in the form of multicolored blades or petals. Such jets, when interacting with the intergalactic medium, accelerate electrons that produce radio emission. They turned the giant into a radio galaxy 16.3 million light-years across. How do stars manage to gather in such huge companies and stay together for billions of years? Scientists don't yet know all the nuances of galaxy formation, but it didn't really start with stars. About 300,000 years after the Big Bang, the universe, which then resembled a hot soup of elementary particles, charged electrons and protons began to combine with each other. They formed hydrogen and helium atoms. Almost all hydrogen was neutral, but ionized and easily absorbed light. Stars didn't exist at that time, so it's called the Dark Ages. Gases and dust gradually appeared, and then among the gas and dust clouds of the early universe, some matter thickened and began to stick together. Their gravity was stronger than in other parts of the cloud and attracted new matter. This resulted in the precursors of galaxies, proto-galaxies. These formations were also heterogeneous in structure, forming clumps of matter in places. These formed protostars, which eventually started thermonuclear reactions within themselves, bursting into flames in the sky. Gravity formed the first galaxies when the universe was 400 million years old, or less than 3% of its current age. Their ancient origin was confirmed in 2023 by the James Webb Space Telescope. Astronomers used it to find the ultra-faint galaxy JD1. A faint object helped us observe the gravitational lensing effect. The Abell 2744 galaxy cluster acted as a lens. This object refracted the light of the more distant JD1, allowing it to display 13 times brighter than normal. It turned out to be a true celestial mammoth, as it emerged just 480 million years after the Big Bang. The age of the universe, then, was only about 4% of its current age. But were all galaxies formed at the dawn of the universe and since then live peacefully each in its own corner of the sky? Recently, scientists have found confirmation of the version that the formation of such objects continues, and now. At least astronomers have found HSC J 1631 plus 4426, which is only a few million years old. It is quite young by cosmic standards. The galaxy is located 430 million light-years away in the constellation Hercules, and differs from most others in the composition of its stars. Her star contains 62 times less oxygen than the Sun. This is the minimum value in the history of observations. Like other chemical elements heavier than helium, oxygen is synthesized in interstellar cores through thermonuclear reactions. This low O2 content suggests that most of the luminaries that make up HSC J 1631 4426 are very young. Another interesting feature of the galaxy is its extremely low mass, 100,000 times smaller than the Milky Way. It looks more like some globular star clusters than galaxies, even dwarf galaxies. The discovery confirms that new galaxies are still forming in our universe. At the same time, this process is gradually coming to an end. The expansion of the universe causes the density of matter to decrease. Because of its absence, there will be no new galaxies. One might even speculate that HSC J 1631 4426 is a member of the last galactic generation. But there was something about this theory of galaxy birth that literally shattered the whole picture. In the late 1970s, astronomer Vera Rubin studied how such objects rotate. It turns out that Andromeda behaves somewhat strangely when moving. Apparently, contrary to the laws of physics, the matter at the edges of the galaxy was moving as fast as in the center, and it shouldn't be. For convenience, insert a vinyl record into your turntable. You'll see that it spins faster in the center than it does around the edges. Nothing like this happened in the galaxy. This means that either Newton's and Einstein's physics doesn't work, or the edges of the galaxy are filled with some other invisible matter. It wasn't called dark matter because of its color. Rather, it was compared to a dark horse, since nothing was known about this hypothetical substance. Well, besides the fact that ghosts don't emit, reflect, absorb light or other types of electromagnetic radiation. X-rays, radio waves, and ultraviolet light pass through the dark matter and do not make contact with it. Astronomers now think that almost all galaxies not only contain dark matter inside them, but are surrounded by its huge invisible halos. It is believed that in the early universe, giant dark curls served as a gravitational framework of ordinary matter to build the first galaxies. One of the best evidence for the existence of dark matter astronomers consider the galaxy Cluster 1 I065756, or BALL. It was formed after the collision of two large clusters of galaxies. Scientists believe this is one of the largest events in the universe since the Big Bang. The scale of the catastrophe has given science the opportunity to learn a lot about galaxies. The main components of the cluster are stars. Gas and invisible dark matter behave differently during a grand collision. Because of this, scientists were able to study each cosmic object of Cooley separately. They discovered that there was a lot of dark matter in the galaxy. To catch the invisible was very difficult, and here again helped the method of gravitational lensing, that is, illumination at the expense of background objects outside the galaxy. But the orb is just a kingdom of light compared to a very dim dragonfly. Astronomers believe that dark matter makes up 99.9% of its mass. The amazing celestial dragonfly resembles a dwarf galaxy in terms of the number of stars. The size of the Milky Way is enormous. The bright, hot gas from which stars are born seems to be virtually absent in Straka's 44. And only the skeletons of old stars fill the galaxy with a faint glow. The opposite of this dim galaxy is NGC 1052 DF2 and the constellation Keith, located 62 million light-years from Earth. Take a look at this picture of the Milky Way. You are unlikely to notice anything special about it. Well, except for the photo glittering with lots of stars. Indeed, NGC 1052 DF2 has hundreds or even thousands of times fewer stars than a similarly sized Milky Way. The trick of the strange galaxy isn't even that, though. There's no dark matter in it at all, just like its neighbor NGC 1052 DF4. In this regard, scientists are still only making assumptions. For example, nearby larger galaxies have been pumping gas out of DF2 and DF4. They've now been detected in parts of their smaller neighbors, and in the latest study, cosmologists have suggested that the two dwarf galaxies collided with each other about 8 billion years ago. This event caused their gas to split up and form many new, even smaller dwarfs. At the same time, DF2 and DF4 had no dark matter. Now it's up to them to somehow survive like this without a skeleton, and even maintain their shape. So NGC 1277 looks like a cosmic lens. We'll talk more about what these are. In the meantime, let's note that there are galaxies of many different configurations. Each one of them has its own unique properties. Let's go to the most interesting galaxies of different shapes to uncover their marvelous secrets. Let's start with spiral galaxies. If only because in this case you do not need to fly anywhere. Our Milky Way is a classic spiral galaxy with a junction. We can't look at it directly from the outside, but scientists have figured out what our world looks like based on models and calculations. Like other celestial spirals, they are a strange, flat, blue-white disk of stars, gas, and dust with a yellowish bulge in the center. They're crossed by a bridge, a band of the brightest stars. The arms of the galaxy, like other similar objects, start from the end of the nucleus, not the bulge. The Milky Way is actively igniting stars. The gas may have entered the core through these casings. It contains about 200 billion luminosities and has a total mass of about 600 billion solar masses. But we won't stay on the Milky Way for long, because we know it well enough. Although, recently Polish scientists voiced an incredible theory. The Milky Way doesn't look the way it's commonly thought. Astronomers have analyzed the galaxy's brightest stars. Research has shown that it is not flat, as previously thought, but twisted and curved. Researchers believe that the Milky Way could have changed shape due to past interactions with nearby satellite galaxies, intergalactic gas, or dark matter. However, this theory has not yet been tested, and the Milky Way remains to us still the same marvelous spiral shining in the sky. Many other galaxies of this type look like it, but not all of it is. To see for yourself, let's head to the constellation of the Dragon, where a veritable tadpole floats across the sky 300 million light-years from Earth. At least one of the spiral galaxies in this constellation is very similar in shape. At one end of the galaxy, many stars cluster together to form a head, and the rest stretched out a long tail at a distance of 500,000 light-years, which is 10 times the diameter of the Milky Way. The celestial tadpole contains a huge amount of gas mixed with several clusters of bright blue lights, so it stands out well in the sky. Perhaps two disk galaxies dragged a smaller dwarf galaxy behind them and formed a space object of such a strange shape. Scientists are still not fully convinced of this version and are looking for other reasons for the birth of a strange tadpole in the sky. Recently, the Hubble telescope was able to spot clumps in its tail. These are supermassive clusters 4 to 5 million years old that will eventually become dwarf satellites of the main galaxy. But it seems it's not just astronomers who study space. If we fly in the constellation of the Big Dog at a distance of 114 million light-years, we will see a huge eye in the sky, similar to the Eye of Sauron from The Lord of the Rings. And next to it is another smaller eye. It is observed in the sky an unusual pair of spiral galaxies, IC 2163 and NGC 2207. They look like eyes with very bright pupil cores. Their two very elongated arms surround the pupils like eyelids. In the past, scientists say, the galaxies were common neighbors. However, relatively recently they maximally approached and began to literally scratch each other. This event caused gravitational tsunamis that rush from the edges of the galaxies to their centers at a speed of 100 kilometers per second. The motion of these waves agitates the interstellar gas and causes thousands of new stars to form in it. The waves themselves lose energy over time, colliding with denser clumps of gas and compacting them further. They spiraled, moving around the center of the galaxy and forming stellar eyelids. The eye galaxy, of course, doesn't actually see anything. Otherwise, it would surely envy the beauty of Messier 63 in the constellation Hound Dog. This spiral object is 57 million light-years away from our planet and looks like a sunflower from a Van Gogh painting. It consists of a central disk surrounded by short spiral arms, petals of blue and white stars. The cosmic sunflower has the unique ability to constantly change color. Astronomers always see its center bright yellow and its petals sometimes milky white, sometimes purple, blue, or brown. But the coolest, perhaps, is the galactic connection of the two hearts. We'll see it in the constellation Pegasus, 400 million light-years from Earth. There, at the center of the galaxy NGC 7674, are two supermassive black holes very close to each other. Their total mass reaches an incredible 35 million solar masses. Perhaps the galaxy acquired a spare heart by attracting to its center the black hole of a neighboring black hole with which it merged in the distant past. Now its hearts are burning in huge jets. These jets of red-hot plasma fly out of both black monsters. Then they merge into a single giant stream, as if symbolizing the union of both galactic hearts. Elliptical galaxies are no less strange and diverse, accounting for about a third of all known galaxies. Their shape is mostly true to their name, but often varies from nearly round to elongated cigar-like shapes. Regardless of configuration, elliptical galaxies are older. They contain relatively little gas and dust, so they rarely ignite stars. There are hardly any young, hot, and bright lights in them. They are mostly filled with old and relatively cool stars like red giants. The color of such galaxies is correspondingly most often reddish. Stars orbit around the centers of elliptical galaxies just as they do in spiral disks, but they do so in more random directions. The masses of such objects range from hundreds of billions to a few million solar masses. This is a wider mass range than other types of galaxies. Speaking of dwarfs, some of them are part of the local group of galaxies, including Andromeda's companions NGC 205 and M32. The largest and rarest are about 300,000 light-years in diameter. Astronomers believe they formed from the merger of smaller galaxies. Their dark halo crowns are so large that they reach their neighbors. These giants often contain globular clusters of hundreds of thousands of stars. On average, the higher the mass of an object, the more globular clusters it has. Isolated elliptical galaxies are very rare. The masses of black holes in the most massive galaxies reach values of several billion solar masses. Galactic gas enters the neighborhood of black holes, stimulating the activity of the nuclei, and they turn into powerful sources of energy. Sometimes these processes are accompanied by the ejection of streams of charged particles from the center, making them powerful sources of radio emission. The nearest elliptical galaxy of this type, NGC 4696 from the constellation Centauri, strikes astronomers primarily by its shape. It is neither a sphere nor an ellipse, lacking the characteristic arms and colors of spiral galaxies. The galaxy is a huge band of dust with a diameter of about 30,000 light-years. Within it, strange thin filaments of ionized hydrogen can be seen. The matter in the fibers is 10 times denser than the surrounding gas. These strange structures create a slightly noticeable marbling effect in the galaxy's bright center. It's hard to imagine the violent events taking place among these layers of dust. It is believed that at the center of NGC 4696 is a supermassive black hole, ejecting jets of matter at near-light speeds. X-ray images show huge voids inside the galaxy. Astronomers see them as clear signs that superjets are ejecting a central black hole into space. A more active object is 12 billion light-years away from Earth in the constellation Sextantus. This is the brightly colored Baby Boom galaxy, a veritable stellar nursery. Ellipses are thought to burn slowly into stars because of the small amount of gas and dust they contain. But it's full of content because it's similar to its lazy counterparts. The insanely prolific galaxy manages to give birth to a star every 2 hours, while the Milky Way, for example, takes 36 days to do so. In other words, the Baby Boom gives birth to 4,000 stars a year. Our galaxy is only 10 years old. It would only take 50 million years for this glowing factory to become the most massive ever observed. According to astrophysicist Peter Kapak of NASA's Science Center, if humans procreated so intensely, everyone alive today would be the same age. There are hybrids in the sky that look like elliptical and spiral galaxies. They're called binaries because they actually resemble lenses. Like spiral galaxies, the objects have a thin rotating stellar disk and a central bulge, although they do not have arms. Lenticular galaxies are also spiral galaxies. However, their core compared to the disk is much larger than that of spirals, accounting for 50% of the total size. 2/3 of lenticular galaxies, like elliptic galaxies, contain little dust and interstellar matter. Their population consists mostly of ancient red giants. The remaining third contains a lot of gas, like spiral galaxies, and likely contains young stars. A new Hubble Space Telescope image shows what a typical lenticular galaxy NGC 6684 in the constellation Centauri looks like. This faint object resembles a real cosmic ghost. And that's because NGC 6684, due to the loss of much of its gas, is virtually no longer forming stars. The pale galaxy was first discovered by astronomer John Herschel in 1836. But Hubble was able to get a great look at all of its details. It turns out that NGC 6684 resembles a ghost due to the lack of dark dust lanes typical of other galaxies. The lenticular ESO 381, 12 in the constellation Centauri, 270 million light-years away from Earth, is also faint, but not like a ghost. It looks more like a delicate flower blossoming against the cosmic void. Its graceful petals form even within the galaxy and extend beyond it. It's quite possible that the bloom was caused by a shock wave from a relatively recent galactic collision. And the lenticular galaxy in one of the latest images from the James Webb Space Telescope is not as marvelous as a flower, but it is more unusual. It resembles a fishing hook. The strange shape of the galaxy probably resulted from the gravity of the El Gordo cluster, which distorted the direction of light. In addition, the fishhook is distinguished by its original red-orange color. This is due to a combination of dust reddening within the galaxy itself and cosmic redshift due to its extremely large distance. Researchers determined that it took 106 billion years for the light from the fishhook to reach Earth. Astronomers also determined the diameter of the galaxy, 26,000 light-years, which is almost 4 times smaller than the Milky Way. And the birth of stars at its center is already in decline. But what if we see something strange during the flights? Not a spiral, not a lens, not an ellipse. Just some cloud with stars inside. Astronomers say that such galaxies are not a unique phenomenon. In percentage terms, they make up 1/4 of all known species and are very diverse. Some have very faint hints of structure, most often spiral. Others have no shape at all. These chaotic objects are usually devoid of a pronounced core, spiral branches. Astronomers have singled them out as a special group and called them irregular. We don't have to travel very far to meet them either. Irregular galaxies include the large and small Magellanic Clouds surrounding the Milky Way. They appear deformed and devoid of a distinct shape. Mainly, their appearance is distorted by the gravitational influence of large nearby galaxies. Although the large and small Magellanic Clouds are more of an exception, most of the irregular galaxies observed by astronomers are on the outskirts of space. In the early universe, before other species appeared, there were many of these formless objects. They later formed as spirals or ellipses, and then some were deformed by gravitational forces. But in any case, they are lively regions of space. Most irregular galaxies are full of gas and dust, making them excellent breeding grounds for the formation of new stars. One of them is NGC 1569, a dwarf irregular galaxy in the constellation Giraffe. This dim, somewhat blurry object is not popular with astrophotographers, but is of great value to science. It is located 7.8 million light-years away, and by some calculations 11 million light-years from us. Scientists say that for the study, the galaxy is relatively close and very suitable for studying the history of star formation. The Hubble Space Telescope has already managed to break NGC 1569 into individual stars and learned a lot about each one. But the galaxy NGC 1156 is bright and original. It shines in the sky with a whole bouquet of red colors. They are formed by many bright young stars that have become something of an island and light up the cosmos. The galaxy's core, on the other hand, is made up of older luminaries. Interestingly, NGC 1156 is an isolated galaxy. It has no close neighbors whose gravity could affect its shape or trigger a burst of star formation. But the top of the irregular galaxies is shown in the famous image of the early universe obtained by the James Webb Space Telescope. The image covered a patch of sky about the size of a grain of sand that a person on Earth holds at arm's length. But the image shows thousands of galaxies as they were at the dawn of the universe. It is the oldest to have come into the Internet's lens due to its irregularly shaped gravitational lens. It is believed to be 135,000,000,000 years old. That is, we see the eye of Z13 as it was just 300 million years after the Big Bang. Astronomers have just begun to study this galactic relic, and one of the fashion brands has already managed to promote it. The unique image, dubbed the ultra-deep Webb field, was printed on fabric and created into a marvelous galaxy dress. The price of the product also turned out to be simply exorbitant. That's almost $80,000. In addition, there are many galaxies that don't fall into these categories. Most often, as astronomers say, such objects are in a transitional stage of their development. It used to be spirals, ovals, lenses, or just spots in the sky. And then, as a result of various internal or external processes, they acquired a completely strange appearance or unusual properties. A new image from the Dark Energy Camera project shows one such galaxy. It's about twice the size of the Milky Way, and it looks like an onion of paradise with 20 layers. This is NGC 3923, the constellation Hydra, located at a distance of 90 million light-years from Earth. Astronomers call such objects shell galaxies. They look like elliptical simulators but have significant differences. The stars in the heavenly onions are not evenly distributed, but are organized structures of separate layers. NGC 3923 is believed to have gotten its strange shape after merging with another galaxy. When the two objects began to merge, the gravitational field of the larger one slowly pulled the stars away from the disk of the smaller one. The stars of the latter gradually mixed with the outer halo of the more massive galaxy, forming concentric bands or shells. A simple analogy. Add a drop of food coloring to the bowl of dough you are slowly kneading. The blob will stretch out in a spiral, which would remain visible for a long time before completely dissolving into the dough. Similarly, the stars were distributed between the layers of the halo. There's another theory. The unusual shape of the galaxy could be the result of a massive white dwarf exploding inside it. And if we see something like a jellyfish in space, it means that we have also found the attraction we need. Astronomers classify such objects as a separate group. and there are over 400 of them. The strange shape of the jellyfish is probably due to the fact that they travel at unimaginable speeds in galactic clusters. When they collide with intergalactic gas, some of their matter is ejected into space. This matter forms a kind of tentacle, speakers tens of thousands of light-years beyond the galactic disk. It's in them that star formation is active, so the tentacles are usually very bright. And, as it turns out, jellyfish aren't just amazing for their shape, they have a completely unexpected property. Like couriers that bring us pizza, galaxies deliver gas from intergalactic clouds to black holes. An international group of astronomers noted the unusual activity of the centers of such objects. Among the 7 celestial jellyfish observed by astronomers, 6 have active galactic nuclei. It's much more than expected. Perhaps ESO 137, 001 from the Southern Triangle constellation, which astronomers are now studying, has a similar property. In appearance, it is a real bluish jellyfish with blue tentacles the color of its stars. It moves in a cluster of galaxies, ABL 3627, with a strong gravitational pull filled with glowing plasma.